Hi folks, we're going to take a look at question 12 from page 99. So what they're asking us to do is they're asking us to sketch any function that satisfies these conditions. So if we take a look at part A, it seems as though the interesting stuff is happening around x equals 1. Okay, so again, all we're looking for is a sketch, so I don't expect anything too precise. Okay. So let's start off here. So the first thing they tell us is that f at 1 is equal to 1. Okay, so at 1, the y value of this function is equal to 1. So I'm going to draw a point there. Then what they tell me is that the limit as x approaches 1 from the right, so as x is approaching 1 from the right, the limit of this function is 3. Okay, so that means that it's approaching 3. So let's say this is 3 up here. So as we're getting closer, it's approaching 3. Now remember, this is a function. So automatically I know that this has to be an open circle since I already have the function defined as 1 at x equals 1. So this has to be an open circle in order to keep this a function. But there's no other condition on the y values to the right of 1. So I can make it anything. So there we go. There's the function to the right of 1, and as I see that as x approaches 1, the function values are approaching 3. Remember, what the function is equal to is of no consequence. The only thing we care about is what it's approaching. Okay. Then to the left of 1, we see that the function has to approach 2. So yet again, we keep in mind that this is going to have to be an open circle, since we already have the y value, and it can be anything to the left of 1 as long as the function approaches 2. So there we go. And there's a function, and you can see I can draw infinitely many that satisfy these conditions, but in the end all I needed was that the function was equal to 1 at 1, approached 3 as I approach 1 from the right, and approached 2 as I approach from the left. Okay, so any piecewise functions that satisfies this set of conditions will work. Okay, so let's take a look at B. Now here they're telling us the function values are always going to be equal to 1 as long as x is less than 1. So that means that to the left of x equals 1, this is just a constant function. Okay, so again, just draw myself a very simple graph. Okay, and I know that to the left of 1, okay, and here it's x less than 1, so I'll start off with an open circle. Okay, so anything to the left of 1, this function will just be the constant function 1. Okay, so now the only condition on the right hand side is that the limit approaches 2. It doesn't tell us what the function has to be, it just tells us that it has to approach 2. So this is where we have some flexibility, because we know it needs to approach 2. So I can certainly leave this an open circle, okay, and any function that, there you go, okay, so as I approach 1 from the right, this function here is approaching 2. Nothing stops me from filling this circle in. Okay, there's no indication that the function even has to be defined at x equals 1. So I could have left it as an open circle, I could have put a closed circle. In the end, either of these would be functions that satisfy the conditions here. Okay, so again, infinitely many. You see that I'm not making any attempt to pick any specific type of function, except on the left of 1 here, I was specifically told what the function is. It's a constant function. Okay, that's it. So one of the tips for these types of things is not to overcomplicate them. Is focus on where interesting things are happening. So in this case here, it all had to do with what was going on at x equals 1, and then for the other parts, as long as it fits the conditions, don't overthink it. Okay, that's it.